Trig, welcome back. This is our second installment of Learning from Home. I will be your host this time around. If you did not see me for this lesson in class, this is for the other group. If you missed something, whatever the case may be. So these were the notes we went over and the little activity we did. So I'll give you some time to hit pause and do some different things, but let's get right into it. I am going to give you a new definition, something new, kind of like vocab, only not. We'll use that string later. This is an angle. We learned about angles, geometry a long time ago. We're measuring how much rotation we would have to turn these rays at. We're kind of measuring that amount of space in there. How much rotational turn are we giving it? And a lot of times well, every time I'm assuming, we measure these things in degrees. I could take a protractor and I could measure how many degrees this little angle is. So it looks like that one's right at 25. Happy accident, but that looks like it's about 25 degrees. I'm going to tell you guys there is actually a different way to measure angles, and it's called a radian. R-A-D-I-A-N. A radian is another unit of measure for angles. So just like we can measure something in feet or yards, two different measurements, but measuring the same distance, we can measure angles in degrees, or we can measure angles in radians, and that's our new one. A lot of what we do this semester is going to be measuring stuff in radians. So here is our definition of a radian, right? Another unit to measure angles in, check. If you take the radius off of a circle and you lay it around the outside of the circle, the central angle you just made is 1 radian. Exactly 1 radian. 1 radius around the outside, 1 radian. So here's our picture of it. Okay, there's a circle. You take this radius, you strip it off, you lay it around the outside of the circle, that angle you just made, 1 radian. 1 radius, 1 radian. So if I did another one, if I took some string like we're going to do in a second and stretch around the outside, that would be 2 radians. 2 radiuses around the outside, the angle would be 2 radians. 3 radiuses, 4 radiuses, 4 radians. 5 radiuses, 5 radians. Okay, we're measuring this thing based on how far we travel around the outside. And we're going to end up calling that the arc length. Okay, so we're going to do a little activity in class, and I want you to follow along and do the little activity I posted for you on Google Classroom with this one definition. Our ultimate goal, what we are trying to figure out. Big idea, big question. How many radians is it to go all the way around the outside of a circle? That's the big question. If we can answer that confidently and know why, we're in step in the right direction. All right, so let's keep that in the back of our heads. I'm going to have a little worksheet that our class is going to do in class, working on this and figuring this out. I'm just going to go through the worksheet with you guys right now. You can probably take some time and see how far you can get on your own first. Cool. And then you can hit pause and play and keep up with me, okay? So just go at your own pace here. It says approximately how many radii fit around the entire circle. Okay, so we're going to use circles A and B on the back of this and a piece of string to verify about how many radii fit around the outside of, we'll do circle A. You can do circle B, doesn't matter either way. So I'm going to take my string, I'm going to grab a marker to make this happen, and I'm going to get about, this doesn't have to be exact, but about 1 radius. I don't want it to stretch too far, but I'm going to stretch it a little bit to the center. Looks like it's about right there. So every time I go from the tip of my string to that orange mark I just put on it, that's 1 radius or 1 radian that I make from the inside with my central angle. So let's see how many this is. I'll try to do best I can again. This is just kind of guesswork. So we're going around the entire circle. That's 1. And I'll put a little mark. Where did I stop and where did I start? Start right there. 1. 2. 3, 4. You can kind of see, hopefully, 5, 6, and a little bit. It's like 6 and a little bit is our answer. I got a little haywire there, but that's okay. 1, 2, 3, 4, 5, 6, and a little bit more. I don't think that's a full radius there compared to the other one. So let's go back to the other side. Approximately how many radii fit around the entire circle? I'm going to say about 6, or maybe 6.5, 6.5, whatever you want to say. It's something about there. Next, it says approximately how many radians would you make with that central angle if you went all the way around the outside of a circle? Okay, so we can look at our hint here as I was going through. If I laid 1 radius, that was 1 radian. If I laid 2 radiuses around the outside, it was 2 radians. 3 radiuses, 3 radians, so on and so forth. So if we said about 6 radii is a full circle, then about 6 radians is a full circle. About. We're talking about approximately. So about 6, 6.5, something like that. Okay. Now we're going to, here's our big question that I just put on that note a second ago. Exactly how many radians would it take to go all the way around the circle? Okay. We'll put our answer right here. Blank radians make up an entire circle and is therefore synonymous with or exactly the same as 360 degrees. 360 degrees makes a circle, and a certain number of radians make a circle. That's what we're going for. If you know the answer, feel free, write down the answer right now. If you know the answer, put it right there, and then skip down to number 9. Okay, you don't need the rest of this. The rest of this is going to be showing you how I'm going to come up with this. So if you don't know, choose your own adventure. We're going to go to number 4, and that's where I'm going right here. So number 4 now says, we're trying to figure out the number of radians that a full circle makes. Turn the following English sentence into a math equation. A full circle is some number of radians. Use the variable x for some number. Okay, so a full circle is, I'm just going to do FC for full circle. That's why I underlined them. Is means equals. They already gave that to me. So full circle is some number. I said use x for some number. Some number of radians. R. Full circle is some number of radians. Okay, radians are the same as the radiuses, radii, radians. They mean the same thing. That's why we call it a radian. Okay. Next, it says what's the geometry word we use for the full circle, the distance around a full circle? Well, your geometry teacher would be proud of you. It's circumference. The circumference of a circle. From that same geometry class where your teacher's very proud of you. What's the formula for circumference of a circle? And you have to use R and C and some other things for that. Okay, well, the circumference of a circle is pi times diameter. Oh, but wait, I said you have to use an R. Okay, well, the other version of it, circumference of a circle, is 2 pi R. All right, hopefully you could be picking up what I'm laying down. Let's keep going, if not. Next it says, fill in the blank, the number of radii around the circle is exactly the same as the number of blank made by the central angle. That's what we just talked about up there. 1 radii is 1 radian. 2 radii, 2 radians. The number of radii around the circle is the same as the number of radians made by that central angle. Okay, so we've put all the pieces together now. It says to put all your answers together from number 4. That's this one. Number 6, that's this one. And number 7, that's this one. We can put all that stuff together and we can answer the ultimate question, what we're doing this for. How many radians are there in a full circle? Okay, our answer to number 4 was full circle equals x times r. Our answer to number 6 was circumference equals 2 pi r. We're going to compare those things. Full circle, same thing as circumference. R, radius, number of radii, number of radians. Here, this is radius. This is the radius of a circle. The number of radii, radians, number of radians. They mean the same thing. That's what this answer is telling us. And finally, there are exactly... Turn my phone off. It happens. We can compare those two equations and say, well, full circle is exactly the same as circumference. The number of radians is exactly the same as the number of radii. And that leaves us with x. How many radiuses? Well, how many is going to be the same thing as this? 2 pi. Mic drop. Hopefully. There are exactly 2 pi radians in one full circle. Hopefully that was what you put on number 3. If you skip down, you already knew that. The answer to this is 2 pi. Okay. So now we can use those to start answering our questions. How many radians would there be exactly in half a circle? So it's just telling me to take half of that. Well, half of 2 of anything is just 1 of anything. It would just be pi. Whoa, that's terrible pi. Half a circle, pi radians. How many degrees is that? Okay, well, half a circle, that's 180 degrees. We're starting to get a conversion factor. There are pi radians and 180 degrees. Something that's going to be weird. Radians are unitless. We actually don't, like, we have a degree symbol. Feet, we put FT. Inches, we put IN. Radians are actually unitless, and we'll talk about that a little bit in class. So you can put a little r just to remind yourself, pi radians and 180 degrees, but in actuality, they are unitless, okay? So we can flip over our assignment now, and we can say, convert 30 radians to degrees. Oh, 30 degrees to radians. Apologies. So 30 degrees. We're going to use that conversion factor we just learned about. I know that there are 180 degrees in pi radians. Okay, I can times those together now. We're timesing a little conversion factor, unit dimensional analysis. Degrees will cancel with degrees. That's good. And now we just have to simplify this. We'll have 30 over 180. That is pi over 6. 30 degrees is pi over 6. Get to 11 that one. We're going to use it a bunch. Next one, convert 45 degrees to radians. 45 degrees. Well, there are 180 degrees in pi radians. We're timesing those together. Degrees cancel. And if you went through and simplified 45 over 180, you're going to get 1/4. It's pi over 4. 45 degrees, this makes sense, is pi over 4 radians. Okay. On circle A, draw 2 radii such that the central angle is 4 radians. Okay. Well, a radian is 4 radii around the outside. So we said, what, 1. We're going to start here. So there's the first radii I'm drawing. So let's draw 2 radii. And the second one needs to make a central angle of 4 radians. So 1, 2, 3, 4. I'm going to end there. This angle should have been straight lines. This angle is approximately 4 radians. Next, on circle B, draw 2 radii again such that the central angle made is approximately 7 radians. So the first one, I'm always going to go straight to the right with this, and you guys will get used to this too. We're always going to go straight right, and we'll start putting these on graphs and things, but the positive x-axis, if you want to think of it that way. We're going to put this on a graph, and we're always going to start with positive x-axis is our first one. Now it said it wanted 7 radians. Okay, well, we said all the way around is 6 and a little bit, so the 7th one is going to be about there. About 7 radians. But this time, it's not just from here to here. We had to go all the way around to get 7 radians. So all the way around would be 6 and a little bit, and then a little bit more to get approximately 7 radians. We'll do the approximate sum. Okay, not too bad. We still got some work to do with this, but we're introducing radians. The big takeaways, what I want you guys to remember, right here, all the way around the circle is 2 pi radians. It's another way, it's just like 360 degrees, it's another way to measure angles. But these ones, in radians, it's going to make anything dealing with a circle 10 times easier, which makes sense. We got this thing from a circle, so when we're using it to describe and do things with circles, it's made for that. It was made from that, it's made for that. So 2 pi radians are 360 degrees. Video number 1, down. Peace.